Hello, everybody. We are now going to enter part 2 of Unit 1. So I'm going to be introducing the night sky. We're really going to get into this content later on in our next batch of videos. But I wanted to go ahead and give you a little bit of a primer so we can start to appreciate the night sky. So we can take part 1 of Unit 1, put that behind us, take all those lessons, and we can start to move forward into understanding our night sky. All right. I'm going to talk a little bit about what's going on with some of these slides that are mostly pictures. And one of the topics we're going to talk a lot about in part 2 is going to be motions in the sky. So I wanted to go ahead and show you a picture that captures the star motions in the sky. So this is a composite image where they put the Milky Way, but then they put what are called star trails on top of it. And I know these are in the deserts of Arizona because I see the saguaros in the foreground. So what is a star trail? If you just take a camera and point it at the sky, the night sky, open up the shutter and let it integrate for a while, so just capture light. As the sky moves, it'll leave the trails that track the motion of the stars. So what can we see in this image? Well, we see that the motion is moving around like so in this clockwise fashion. And it looks like all the motion is centered, the entire sky is rotating about this point right here, which I know that is what we call the North Celestial Pole. That little tiny star that doesn't really have any star trails right there is Polaris, the North Star. So this direction right there is north. Also, a few other things you can note is that look at how small the star trails are here, and then they get larger and larger and larger. So these stars are changing their position in the sky faster than these stars in the sky as we move away from the celestial pole. Just little things that we're going to be talking about here in this part 2 of Unit 1. Also, just what kind of things are up in the night sky that we can see naked eye? What are some of the initial things that we're going to talk about to acquaint ourselves with the night sky? So we're going to be looking at the stars. Those are the obvious things that pop out at night. The human eye can see about 4,500 stars in perfectly dark skies from a location on Earth. If you add in the other half of the sky that would be viewable from the other side of the Earth, then there's about a total of 9,000 or so naked eye visible stars. We know that there are a lot more stars out there from our first video of about 400 billion just in the Milky Way galaxy alone. And that's another thing you can see. You can see the plane of the Milky Way. Here in this panoramic, this is the plane of the Milky Way. The Milky Way being flat like a disk. We are located about 2/3 the way. And whenever we see the Milky Way, we're looking towards the center of the Milky Way, which creates this milky patch where there's so many stars clustered so close together that our eye can't differentiate them as individual points, so they blur together into this milky path in the sky. That's broken up by these dark dust lanes. What are some of the other things that we can see? We can see star clusters like the Pleiades. We can see planets like Mars. And then we can see things like constellations, Cassiopeia. We can see asterisms, the Big Dipper and the Summer Triangle. So there's a whole variety of things that we can see up in the night sky. And then we have our transient objects, the things that come and go. The fastest of our transient objects would be our meteors. You look up, you see a bright flash, a shooting star across the sky, same thing as a meteor. Those happen as well. And then there are things that might come and visit us. Hopefully some of you got to go out and see the comet that was recently visible, Comet Neowise. I'll try to show some images of that in one of the upcoming videos. I was out doing photography of it. But we have transient objects like comets. And a little bit more, so here's one of those transient objects. This is Comet McNaught that graced the Southern Hemisphere skies in 2007, which brings me into, if we were to go down to the Southern Hemisphere and look at the sky, all of a sudden we might recognize some similar things, like yes, we could still see the Milky Way, but all of a sudden everything just seems to be on opposite sides. But we would also look up and look for our familiar constellations, and most of them we couldn't find. There's a different pattern of stars in the sky. You might also notice that there are some of these strange cloud-like features called the Large Magellanic Cloud and the Small Magellanic Cloud, or LMC and SMC for short, which are satellite galaxies in the Milky Way. Just like the Earth has a natural satellite, the Moon, the Milky Way has satellite galaxies. And these are two of the closest satellite galaxies. We can't see them in the northern skies, but if you're in the Southern Hemisphere, you can look up and see those at night. Clearly, there's a difference between the skies in the Northern Hemisphere and the Southern Hemisphere, which tells me that what skies we can see depends on our latitude on Earth, how far north and how far south we are. All right, speaking a little bit about north and south, I want you to go ahead and think about this question. I want to orient ourselves and really talk about what the cardinal directions are. I know this seems like throwing back to way basics, but what are north, east, south, and west? We're trying to navigate space, so what are some of our spatial directions? Now, if we were to fly in from a spacecraft into our solar system is oriented, it's flat like a disk, so all the planets would be orbiting the sun, which would be in the center. But if we're going to fly into the solar system, who's to say that we're going to fly in this way versus, say, come from the bottom right here? Or maybe we come at a different angle, but we have no idea if we're coming from the top, if we're looking at the top part or the bottom part of the solar system as we approach. So if we're approaching from outer space and we're looking at, say, the planet Earth, how can we differentiate the cardinal directions? How can we assign the cardinal directions? You might look for where the North Pole, which is kind of what we think about, but how do you know that's not the South Pole? So how could you determine your cardinal directions? If you can't determine north from south by looking at the poles of the Earth, what are you left with? And all of a sudden, cardinal directions seem a little bit more difficult. So maybe you approach from above, maybe you approach from the south. Can you really determine north? You can't really differentiate north to south. If you want to, go ahead and pause and think about the question for a second. This is one of those things that kind of stunned me a little bit as well, because I always think from an earthly perspective, we think of north as basically the foremost of the cardinal directions. We set our other directions by north. That's because we can use a compass in Earth's magnetic field, or the North Star. So hopefully you took a little bit of pause and you thought about it. You're still thinking about it. Now let's go ahead and take a look. So let's imagine that we're coming in, and here we're coming in, so we see the sun, and now we're looking at the entire orbit of the Earth around the sun. And we want to figure out what the cardinal directions are. So we have to ask ourselves, what is it that we can observe? Well, we could see that the planet is rotating this direction. So it's in the way I've drawn it, is rotating counterclockwise. And once we can see the direction of the planet, then we can assign our cardinal directions. Because from a space view, if you're going to go visit some other planetary system, you're not going to identify north first, the foremost of the cardinal directions, because you cannot determine north or south, because you don't know if you're coming from above or below the plane of the system. You can't define that yet. What you can see is the direction that Earth is rotating. And the direction that a planet rotates, that is what we define as east. So Earth rotates to the east. So that we define the direction that a planet rotates, in this case Earth, as east. And once you know east, then you can use that to define north, south, and west. So from a space-based perspective, east is our first direction that we establish. We define the other ones from there. We don't live in outer space, though. We live on Earth. So how can we figure out our cardinal directions? How can we navigate, do some just basic skills that really gave rise to civilization? How can we find, say, north living here in the Northern Hemisphere? And I would be remiss in my duties if I did not teach you how to find north using the Big Dipper in an astronomy class. We don't do a whole lot of stargazing in this class, but this is one of those skills that I expect you to be able to master. It's really not that hard. So what we want to do is we want to determine north, and what we're going to do is use two asterisms, patterns in the sky, to do so. We have the Big Dipper, And we're going to use the Big Dipper to point us towards Polaris, the North Star, which is in the Little Dipper. So the way you want to do this is you find the Big Dipper in the sky. Remember, everything's going to be rotating. Think about those star trails, but you can always find the Big Dipper pretty easily. Then you're going to go to the cup of the Big Dipper. You're going to go to these two stars that make up the edge of the cup, the far edge of the cup. Use them as a pointer, so draw a line that goes through them. Keep traveling, keep traveling, keep traveling, keep traveling, keep traveling, keep traveling. And the next brightest star you'll find in the sky is Polaris, our North Star. No, Polaris is not the brightest star in the sky, so you can't just find the brightest star in the sky. That's serious. Polaris is somewhere, I think, between the 30th and 40th brightest star in the sky. So it's not a super bright star, but it is going to be the first star that you can easily see going from the cup of the Big Dipper, the edge of the cup of the Big Dipper. So looking out towards our horizon, which is really, really far away, we just go directly below it and we've identified north. If you want to travel north, look directly at Polaris and start walking. You're walking north. And now you can navigate north and south. Put it directly at your back and walk directly away from it. You're traveling south. And rotate the 90 degrees, and now you can travel east and west. Nice. We have figured out navigation using the North Star. And you heard me say some words in the previous slide: asterism, patterns in the sky. And you might be thinking, Dr. Lindsay, those are constellations. We refer to patterns of stars in the sky as constellations. But constellations are different. So I want to talk to you a little bit about the patterns that we see in the sky, our constellations and our asterisms. And it's important to note that these patterns that we see in the sky, they're the same night after night, year after year, right? I mean, all the constellations were defined thousands of years ago, or at least the ones that we adopt and that we use regularly. And the patterns remain the same. Orion always looks like Orion. Because the stars seem fixed in the sky, they're so very, very, very far away, we can't see their motions, so they appear to be fixed. We call that the fixed background of stars, which we're going to use frequently in this class because it's nice to have a fixed backdrop that we can measure against. Okay. So we recognize patterns in the sky. Humans are great at pattern recognition, so it's no surprise that we start picking out patterns when we look up. But let's talk about what constellations are. So constellations are officially recognized areas of the sky. And whenever I say area, you need boundaries around it. So they're going to contain a recognizable pattern of stars, but they're also going to have boundaries on them. Just like if we're going to look at the map of the US and go to Tennessee, our stars would be our cities, and then the borders of the state would be the boundary around it. So we have the boundary, the borders, and then we have the stars that are within it. And all the stars that are within the borders are part of the constellation. However, that pattern of stars that we recognize, say Orion the Hunter, where we can see the bow and the belt, we refer to that recognizable pattern of stars within the region called the constellation as our constellation figure. So these are the names you think about. You hear Orion, you picture Orion's belt, and you picture the bow, and then some other ones: Sagittarius, Virgo, Gemini. Probably heard of those ones, but maybe not: Cygnus, Ursa Major, Hercules, Perseus, etc. And since these have boundaries, we can then break up the entire sky, every part of the sky you can see from the north and the south, into unique regions. And we do that, we break the sky up into 88 different official constellations. And here, official, these are the ones that are recognized by the International Astronomical Union, the IAU. So we can break up the entire sky into 88 different regions, and we can figure out where those regions are by looking for the constellation figure, which tells us that we're in that constellation. Now, what's the difference? What's this asterism thing? Any commonly known pattern of stars that has a name but is not already one of the constellation figures So it's a pattern of stars that you can say, and people will go, oh yeah, the person's talking about a pattern of stars. That is what an asterism is. It can't be a constellation figure. It doesn't necessarily have to be contained within one constellation. It can stretch across constellations, but it's just a pattern of stars that's not already a constellation figure that has a commonly known name. Some examples: the Big Dipper, the Little Dipper, the Pleiades, the Summer Triangle, Orion's Belt, the Belt of Orion. Everybody has heard of Orion's Belt, but that is not a constellation figure, but it is a commonly known pattern of stars. So Orion's Belt is an asterism. And of course, pictures are much better than words, so let's take a look. And let's start with the asterism, the Big Dipper, right here. So go to the end of the cup, got Merrick and Dubé. Go ahead and draw a line. All right, north is going to be somewhere right over here. So you can still do that. Great. So this is our constellation, the Big Dipper. But the constellation Big Dipper the asterism called the Big Dipper lies in the constellation called Ursa Major. And in fact, it is a part of the constellation figure of Ursa Major. So I can draw out the entire constellation figure. Here's Ursa Major. And here we have the Big Dipper part. But then all of these stars right here make up the constellation figure called the Great Bear, Ursa Major. And here's a strange thing. As far as I know, bears don't have tails, but here's the tail of the bear. And if you go according to the Greek legend, this Ursa Major is in the sky because somebody chucked the bear into the sky by chucking the bear by its tail. Oh, well. Well, there's our Ursa Major. Maybe that doesn't look like a bear to you, but that's what it's supposed to look like. Okay, so now we have our asterism, the Big Dipper, in the constellation figure Ursa Major. What we need to do is Big Dipper, Ursa Major, draw some boundaries around this. So draw our state borders on the sky. And we have this entire region of the sky that's highlighted in white is our constellation, which is containing the constellation figure Ursa Major. Now these stars over here, like this star here, this star up here, they are part of the constellation Ursa Major, but they are not part of the constellation figure. And remember, there are 88 of these that make up the entire night sky. So we have 88 states on the map of the night sky. That's all I wanted to introduce you to. We'll really get into navigating the stars next week. It gets a little bit more technical. Thank you for tuning in, and don't forget to do the engagement exercise.